Good morning, good afternoon, and good evening, friends. Today we are going to see how to find the equivalent capacitance in a different circuit combinations. So I will be walking you through three different problems or three different circuits in which capacitances are connected in a different way, and we will see how to find the equivalent capacitance. So let's start. So let's start with this first problem. So here we have this circuit given, and the question is find the equivalent resistance between point A and point B. So how do you solve these kind of problems? So basically here we have to find out. So if you see, so I have marked this as point V1, this point as V2, and this is again V1 because if you see there is nothing connected or no capacitance or resistance is connected, so this is basically a short circuit here. Similarly, from V2 to V2, so if you see this is again a short circuit. So basically what is meaning of short circuit is the potential is the same across these 2 points. So this will help us drawing or redrawing this circuit. So let's start from point A, right? So I have started from point A. Now again V1, since we have given point this is V1. So what is connected between V1 and V2? So as I said before, there are two short circuit links here, link 1, link 2. Okay, so for first short circuit, let's assume voltage is V1, and for second voltage is V2, as I said here. So I'm starting from V1. So V1 to V2, how many capacitances are there? So V1 to V2, we have C capacitance, right? Again, V1 to V2, the potential is same. So V2, V1 to V2, so this point is again the same V1, right? So V1 to V2, V1 to V2, when potential is same, that means capacitance are connected in parallel, right? So this C is will become, this C is in parallel with this C. So that's how I have drawn. And again, if you see this other C, the third C or third capacitance, this is again the potential is V1 and V2. How? Because there is this short circuit, this makes this V1 becoming the same potential V1. Similarly, this is another short circuit which makes V2 potential the same as V2 here. So we can redraw this circuit as C in parallel with C in parallel with C. So basically this is the equivalent or the redrawn circuit where we will see that these three capacitors are connected in parallel, and we know how to find the equivalent capacitance when capacitors are connected in parallel. So basically it will be C plus C plus C. So equivalent capacitance will be 3C. Okay, so let's go to the next circuit. So here the circuit is little different than the previous one. The previous one was like this. There were only 3 capacitances. Here we have 5 capacitances. So let's do the same thing now. So if we see again here there are 2 short circuits. So I have marked the potentials are again same. Like this potential V1 will remain same as V1. This potential V2 is same as potential V2. So if we redraw this circuit, so let's start from point A. Point A, then we have capacitance C, then V1. So V1 to V2. V1 to V2, how many capacitances are there? So if you see here, there are 2 short circuits as explained. So let's assume V1 is the voltage at first short circuit, V2 is the voltage at the second short circuit. So if we closely observe that these 3 capacitances, like these 3, 1, what is the voltage across them? V1 minus V2. What is the voltage across this capacitance? V1 minus V2. what is the voltage across this capacitance V1 minus V2. So since the voltage across all these capacitors is V1 minus V2, we can say that these capacitors are in parallel. So this first C1, it will come here at point V1, then V1 to V2, V1 minus V2 is the voltage difference. So these capacitances are in parallel, and then there is one more capacitance connected between V2 and B. So how to find out the equivalent capacitance? So we will say C, this capacitance, in parallel with the equivalent of these three capacitance, oh sorry, in series with these equivalent capacitance, and again that will be in series with C. So equivalent capacitance will be calculated as 1 upon C equivalent equal to 1 upon C plus the equivalent capacitance when these three are in parallel, which will be C plus C plus C, plus this is again one more in series, so 1 by C. So if we solve this, you will get C equivalent equal to 3 by 7 C. So yeah, that's how you solve it, these kind of examples. Let's go to the next one. So next circuit is like this. So it is another way of drawing circuits. Is kind of a drawn in a circular format, and the question is find the equivalent capacitances between M and N. So what I have done here is I have tried to give the different names for the different connecting points or nodes. Like for example, we have to find the equivalent capacitance between M and N. So this point again becomes M. This is again point M, because this is simple wire, there is no capacitance in between. This point is N, so this will again become N, and I have marked this node or point as A. Okay, so how to redraw this circuit? So start from point M, so M, then C to point A, right? So there is capacitance C till point A. So M, this is again point M, so there is one more capacitance between M and A, right? M and A, so that's what I have written or drawn, M and A, and which is in parallel. If you see, these are in parallel. So what is there from point A? So from point A to N, there is one capacitance, so I have redrawn here. What is there between point M to N? So between point M to N, there is one capacitance C also, which is in parallel with this whole circuit. That's how you redraw it. So once we have this circuit, you can again go and redraw the circuit, like these two are in parallel. So basically we can put a equivalent resistance of these two, which will be C plus C equal to 2C. That's what I have done here. So since we solved this circuit, so that will become 2C. So again, with 2C is in series with C, and there is one more capacitance series, sorry, in parallel, which is already there here, right? How this 2C came? C plus C equal to T 2C, since these were two in parallel. So again, if I further solve, now 2C and C are in series. So how you find out when two capacitances are in series? So equivalent of 2C and C is equal to 2 by 3C. This is by our mathematics. Now the equivalent capacitance of 2C and 3C I have added here as 2C by 3. Now 2C by 3 and this C, these are in parallel. So how you find out the parallel equivalent capacitance of these two is you just add them. 2C plus C is equal to 5 by 3C. So this is the equivalent capacitance of this circuit. So yeah, please let me know if you have any questions about how I have redrawn this circuit and how I have came up with this final equivalent capacitances for these three different circuits. Let me know in the comments, and let me know what you want to learn the next topic from the electrical circuits or physics. I will try to create a video. Thank you and have a good day.